Hey guys, Mr. Gucci here to help you with your 6.3 homework, all right? The polyatomic ion. So I'm going to show you how to do ionic compounds with polyatomic ions. Guarantee it's easier than it looks, okay? You're basically doing the exact same thing you did before, just with more letters and numbers involved, okay? But it's no more complex, okay? Now, before we get started, there's a few things that I have open right now that are going to help me with this homework, okay? First of all, I've got that monoatomic ion chart from the previous homework, okay? Next, I have the polyatomic ion list that's been attached to this homework as well, all right? And I have this little ionic compound workspace for me to work out some things. And of course, as always, you should have a periodic table open somewhere, either digitally or maybe have your textbook open, flip open to a page with a periodic table. All right, anyways, let's get going. So, just like on the last homework, we have a situation where you are given two ions. You are given calcium with a 2+ charge, and you are given this thing right here, CrO4, with a 2- charge. Well, I'll tell you what, let's do the easy thing first, okay? The ionic compound, well, if this is 2+ and CrO4 here, if this CrO4 has a 2- charge, well, then the formula is going to be simple. It's just going to be CaCrO4, okay? Format, text, substance. You're going to need one of each. If one is 2+ and one is 2-, they're going to cancel each other's out. Now, the names of this, well, Ca I know is calcium, okay? CrO4, however, that's a new one. This is a polyatomic ion. And basically, you have to look up its name on a chart here. Let's find CrO4. 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 Do we have it? Do we have it? Here it is. It's chromate. The name of this polyatomic ion is chromate. Now, you might be thinking, Mr. Gucci, do I really have to look up all of these things? No, the other option is you could do like previous students have done in previous years and memorize every single one of them. Those are your two options, guys. Memorize them or look them up, okay? I think you have the easier option this year. And over time, you'll become familiar with the names of some of these things, okay? Definitely the more common ones you'll become familiar with. And then you won't have to look them all up, okay? Now, does this calcium get Roman numerals? Let's see here. No, calcium has a +2 charge always, so no Roman numeral needed. Done, okay? Done. Next up, Li and HPO4 2-. Let's do the name first this time. Well, Li I happen to know is lithium. Okay, and HPO4, the heck is HPO4? Let's go to the polyatomic ion list. Let's look for HPO4, here it is. Hydrogen phosphate is its name. That whole thing, all right? So this is lithium hydrogen phosphate. Oh, look at that, going on to a second line. That's new. All right, here we go. Now, does this get a Roman numeral? Lithium is +1. Is it always +1? Let's take a look here. Yes, lithium is always +1, so no Roman numeral needed. Okay, no Roman numeral needed. Okay, now, let's figure out the formula for this ionic compound. Lithium has a 1+ charge. Hydrogen phosphate has a 2- charge. Well, I'm going to go to the ionic compound worksheet. Lithium is 1+, hydrogen phosphate is 2-. So 1 and 1 won't work. I need to get a second and put it in here. Let's see here. Okay, so here we go. This is the formula of lithium hydrogen phosphate. Li2 HPO4 1. There's 2 lithiums and 1 hydrogen phosphate. So let's take a look and see how do we enter this in. Well, lithium, there's only one, so lithium. And hydrogen phosphate is HPO4. All right, it's HPO4. And you only have one of them. So that's it. This 4 is not how many hydrogen phosphates there are. This 4 is part of the single hydrogen phosphate, okay? Hydrogen phosphate is HPO4. That's what it is, okay? So if you have 1 hydrogen phosphate, you have an H, a P, and an O4. It's kind of like saying I have a car. It has a chassis and 4 wheels. All right, I don't look at my car and say, oh, I have 4 cars because I have 4 wheels. That doesn't make any sense. The 4 wheels are part of a single car. And these 4 oxygens here are part of this single hydrogen phosphate. So that's the formula right here. Li2, because there's 2 lithiums, okay, HPO4, okay. Next one, Be, 2 plus, and SiO3, 2 minus. Well, Be, that's beryllium, okay. SiO3, let me take a look here. SiO3, is silicate, okay. So this is beryllium silicate. Great. Does it need a Roman numeral? Well, that depends. Does beryllium always have a 2 plus charge? Let's take a look. All right. Be, beryllium. It always has a 2 plus charge. Okay. Beryllium always has a 2 plus charge. So no Roman numeral needed. Okay. Now the formula. The formula here ends up being pretty simple. Right? It ends up being pretty simple because beryllium is 2 plus. Silicate is 2 minus. You got one of each and they cancel each other out. So the formula is Be SiO3. This is 1 beryllium and 1 silicate. Again, silicate is SiO3. All right? That is what 1 silicate polyatomic ion is. So if you have 1 silicate, you have an Si, and then you have O3. That is what, just like, again, if you have a tricycle, it has a body, and then it has 3 wheels, okay? You don't have 3 tricycles. You don't order a tricycle and only get 1 wheel. Those 3 wheels are part of the single tricycle, okay? Next up, here we go. NH4, CO3, 2 minus. Well, this is tricky because these are both polyatomic ions. What is NH4 with a +1 charge? What is NH4? I go to the polyatomic ion list. NH4, here it is. It's the only positive polyatomic ion. It's ammonium. So this is going to be ammonium. All right, and CO3, 2 minus. Let's find what is CO3, 2 minus. CO3, C's. CO3, that's carbonate. So this is ammonium carbonate, okay? No Roman numerals. We know the charge of ammonium. Now, what's the formula here? Okay, this is going to be the first time we do this particular way. It's going to be a little tricky. Let me show you, okay? Ammonium, NH4, has a +1 charge. Carbonate, CO3, has a 2 minus charge. So let's combine some compounds. NH4s are +1s, okay? So let me get a +1 here. All right, carbonate is 2 minus, so I'm going to get a 2 minus in here. All right, that doesn't work. I'm going to need another one of these. Okay. Oh, this works. So we needed 2 ammoniums and 1 carbonate. Now let's take a look and see how we write this. Now, I want to write that I have 2 ammoniums in this compound. All right, NH4, okay, CO3. Okay, let's see here, format. How do I communicate that I have 2 ammoniums here? All right. Now, what you're not going to do is you're not going to double these numbers. You're not going to say NH2H8. That is what you're not going to do. To tell me that you have 2 ammoniums, here's what you do. Are you ready? You put NH4 in parentheses, and then you give it a 2 on the outside. If this is 1 ammonium, well, then 2 ammoniums is going to be that doubled. You don't distribute this 2 in. Again, this is not N2H8. Not. All right? It is NH4 in parentheses, 2, and then 1, a single CO3. Okay, guys, look. The big thing with polyatomic ions is this. All right? The formula of the polyatomic ion will appear in your formula. Okay, so if this has NO3 in it, then there is going to be somewhere in your formula NO3. Maybe you'll have more than one, maybe not. But NO3 will appear somewhere in your formula because that is, in this case, nitrate, okay? Here we go. Let's do this next one, okay? I'm going to do two more here, and then I'm going to move on, okay? So, Cu is copper. NO3 is NO3, 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 and first one, nitrate. So this is copper nitrate. Now, question. Do we need a Roman numeral? All right, well, copper is 2 plus here. Is it always 2 plus? Let's take a look. Copper, Cu, 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 Cu. I don't see it. I don't see copper here, which means that it's an ion that can have multiple charges. You will need to have a Roman numeral in the name. Okay, so this is copper 2 nitrate. Okay, now it's time for the formula. So Cu is 2 plus. Nitrate, NO3, is 1 minus. Let's do this, all right? Let's do this. Cu is 2 plus. This is a copper 2 plus. And NO3 is 1 minus. So 1 and 2. Okay, there we go. So yes, you need 1 copper and you need 2 nitrates. 1 copper and 2 nitrates. 1 of the positive ion and 2 of the negative ions. Okay, so it's going to be Cu for the copper, and then you're going to need 2 nitrates. Okay, so again, here's what this looks like. All right, you're going to have NO3, and you're going to put it in parentheses. All right, you're going to put it in parentheses because you will need 2 of these. You're going to need 2. Okay, so NO3 is just 1 nitrate. NO3 in parentheses 2 is 2 nitrates. So this is the formula right here. This is what it looks like to have 2 nitrates. Okay, this is what it looks like to have 2 nitrates. Okay, very good. So let's do this last one. Actually, I'm going to skip that. Let's see what's another one. Okay, I'm going to do number 12 here. All right, so Al3 plus, aluminum, and ClO3 minus. What is the name of this polyatomic ion? ClO3 with a -1 charge. ClO3, there's right here. Chlorate. So the name of this thing is aluminum chlorate. Okay? Now, what is the formula going to be for aluminum chlorate? Aluminum is 3 plus. Chlorate is 1 minus. So let's go to the work page, okay? Aluminum is 3 plus. Chlorate is 1 minus. So here we go. 3 plus, okay? 1 minus. Okay, that's not good enough. Let's get another one in here. We need more. Let's see. Okay, so here we go. So we needed 1 aluminum, and to balance that out, we needed 3 chlorates. So once again, here's what this looks like, all right? Al, and then ClO3, that is just 1 chlorate. We need 3, so it's ClO3, 3. Okay, and I'm just going to make sure that these numbers here are subscripts. Okay, very good, guys. So this was your first help video. You can see here that the key to doing compounds with polyatomic ions is we're still doing the same kind of crisscrossing or like clicking and dragging to put things together. The only difference is that you are dealing with a cluster of atoms acting as one. So if you have multiple of them, well, you slap them in parentheses and treat them as one unit, okay? That's what you have to do to get the formulas of ionic compounds with polyatomic ions. Okay, guys, this is your first help video. I'm going to make a couple more. Good luck.